So welcome to Blazing Gamer, and in this Unreal Engine tutorial I'll be showing you how to generate a voxel terrain like in Minecraft using the Unreal Fast Noise plugin. Basically by the end of the video you would be able to generate something similar to this, not exactly this, but yeah, something similar to the world. By any means this implementation is not game ready. There need to be done several optimizations to make it game ready. Also, this is not infinite, but it can be turned into infinite. I'll talk over some optimizations, and maybe in a future video I'll show one or two, but let's just get started. So first you need to create a blank C++ project. We'll be doing this solely in Blueprint, but you do need a C++ project to build the plugin so that you'll be able to use it in the Blueprint. So just create a blank C++ project, and just created that, and I have just created some folders, and I created a blank the default level, as you can see here, the default level, and I just took the cube mesh from the starter content and its material and placed it in a separate folder. So once you have done your project setup, head over to the Unreal Fast Noise forum. This forum link will be shown in the description, and you can just go to the GitHub link and download the Fast Noise plugin. Just download the zip. Once you download it, you would get this inside the zip, and all these folders will be there. So just open your project directory and create a new folder called plugins. The P needs to be capital and the name needs to be same, because this is where the engine is configured to search for plugins. So just open this folder and move this Unreal Fast Noise inside this folder. Once done, go to the U project file, right click and generate Visual Studio project file. You do need to restart the engine, so just close the engine. Once the project files have been generated, just restart the engine. Okay, we'll get some errors. So once your engine is started, just go to the plugins, and under project plugins you will see this noise category, in which you will see Unreal Fast Noise plugin. Just enable this and it will tell you to restart it. This time while restarting you'll get missing DLL, which says you just need to rebuild the engine, and this may take some time, and depending upon your hardware. And also if your build phase, you'll need to just manually build it inside Visual Studio, otherwise mostly it doesn't phase at this stage, so it will take some time. And once the build is done, you will be able to use the plugin. You can see the build is done and the engine will start now. So make sure the enabled is ticked, and to check whether the plugin has been successfully installed, just open any blueprint like the level blueprint, and we'll just get rid of this and type noise. And if you get this category of Unreal Fast Noise, under which you will have many nodes or functions, and just open any node and see if it's opening properly, and if it does, then you have installed the plugin correctly. If you haven't, just Google the error, whatever you're getting. So once you are done with this, just create a new level. The default level would work, and I have already created that. We need to save this. Okay, so I just got rid of the floor, and then now we need to create an actor blueprint. So in your blueprints folder, just create a blueprint class actor, name it anything you want. So open the actor. So the way we'll be adding the cube meshes would be through instance static mesh. Now why are we using this over static mesh is because instance static mesh only loads the mesh once in memory and allows you to create multiple instances without using extra memory. It is way more optimized than normal spawning normal static meshes, and there's a huge difference. If you do this using normal static meshes, you won't even be able to run, because you'll get very low FPS and it will take a lot of time to build the world. So instead we'll use instant static mesh. So just add the component and search for instanced static mesh. Okay, now you can make it the root component also, it won't matter. So once that's done, we need to go to the event graph. We won't be needing these two, just the begin play would work. So how does the world generation work? So first of all, we iterate through x and y coordinates, and we pass those coordinates into a noise function, which basically gives us a z coordinate. And now that z coordinate is unique for each and every x and y coordinate. And depending upon the z coordinate, we create the instance of the static mesh that we specify. So that's just basically how noise generation works. So we do need to give the static mesh in the instance static mesh component. So just search for cube. Okay, so once we are done with that, the thing is we need to start the begin play. So the first thing we'll do is iterate through two for loops, nested for loops, which will basically give us our x and y coordinates. So we'll just search for loop. Now do select for loop, not the for each loop. And inside the loop body of first for loop, we'll go into the loop body of second for loop. So this index would be the x coordinate and this index would be the y coordinate. Okay. So now there are some variables that we'll need to create. First would be the world size, which would be the last index for these for loops. This would be an integer. So we'll compile it. So now world size, by default, I'll keep it as 100. And depending upon the world size, it will take more time to generate the world. So right now we are doing fixed size world. So we'll specify a world size. If we are doing an infinite world, we will build around the player rather than building a blueprint. We'll just edit that. Those things goes in player blueprint. If you want, I would cover those, but I haven't quite figured out myself that yet. So just plug this into the last index. Now one more thing is, since suppose the world size is 100, so this loop will iterate through 0 to 99. So we'll get integers 1, 2, 3, 4. But we can't just directly put them in the coordinates of spawning the instance. We'll need to multiply it by the size of the cube, because if we are spawning a cube at 1, 0, 0 and the second cube at 2, 0, 0, the cube may be of larger size, so the two cubes may just spawn inside each another. So we need to multiply it by the cube size. Now to look at the cube size, just open the cube mesh and you can see the approximate size is 100, 100, 100. If you're using your custom cube, then just check the cube size of that cube, but the cube that the engine provides is a 1 meter by 1 meter by 1 meter cube. Unreal Engine works in centimeters. So we'll need another variable called the cube size, and this would also be 100. So if we get this, now we can expose this to the inspector if you want to edit that. So just get the cube size, take the index, multiply it by an integer, and we'll take this pin again and copy it. Okay, so the cube size would go here and this. So this would give us the x coordinate and this would give us the y coordinate. Now in the loop body, now we need to calculate the z coordinate. For that we need a noise generator. So search for noise and we'll be using the simple noise generator. You can use the normal one also, that just gives you more values to play with. So this is a simple noise generator and this would give us a noise generator object from which we can extract the noise. So the noise type would be simplex. Now Minecraft works on Perlin noise, but the Unreal Fast Noise plugin does not support Perlin noise, though it is built upon the Auburn's Fast Noise library. I don't know why it doesn't support Perlin noise, but there won't be much difference in computation time But the thing is, Perlin noise gives us more variation than simplex noise. So we can do this in C++, and I'll show you at the end of the video the result, the difference between simplex and Perlin noise. So the first thing we need to do is give a container to the noise generator. So the container would be self. Now I don't know why we need a container for this, but if you don't specify a container, your engine will just crash. So be sure you have specified self in the container. Noise type is simplex. Seed is anything that you want to give. You can even create a variable. Let me just do it. Seed, and we'll call it an integer. Just compile it, make it public. We just give it any value that we want, and we just put this seed in. The seed, similar with the frequency, we can create a float. This would be a float. You can just get the frequency and put it in here. Now frequency basically decides the variation, like how much variation is. Also these two values don't really matter, you can play with them, but if you put in a low frequency, you'll get somewhat planes would be generated, and if you put in a high frequency, you would get somewhat like mountains. So for high frequency, I would recommend 0.0005. Now this may be a low value, but any frequency, like, just play with it. I've seen 0.0005 gives you good mountains. So now that we have the noise generator, we get the noise from it. So just type get noise, and we are using 2D noise since we are only taking X and Y. So just put the loop body in get noise. We put the X in X, the Y in Y. Okay, so now we get a Z value, but the output of noise function would be somewhere between -1 to 1. So we'll multiply this by a height scale. Suppose now we'll be choosing a height scale of 10. So we'll get the values between -10 to 10. So let me just do that. Multiply this by a float. That would be 10. So why I do this is, now we'll get Z values between -10 and 10, which we'll multiply by the cube size. So we'll get height values between -1000 and 1000. So 1000 would mean the top height of the world, and -1000 would mean the lower height of the world. So you can take a greater height scale, but you need to do this. So we are getting here a value between -1 and 1. So it's a float multiplied by 10. So we get a float between -10 to 10. So we need to round it because we need the Z coordinate to be rounded integers like 100, 200, 300. So we just round this arguably. The round function gives us an integer, which will multiply with the cube size. So just multiply this with the cube size. Okay, now the value we get here is the actual Z value, or the height at which we will spawn. So if we just take the instance static mesh and do add instance, so it will require an transform. So we can make the transform easily. So we'll just do make transform. We don't need to change the rotation or the scale, so we just need to make a vector. So we just do a make vector, and you get this. So basically this would be the Z value. X and Y values we have here. So this is the X value, this is the Y value, and that's basically adding the instance. So we need to put the execution. So this will basically create the top layer of our terrain. It won't fill the world. Like you can see, just the top layer will be created. You can see the output of this. So if we go to the blueprints and first save everything and add this and move it here to 000 and press play. So as you can see, the top layer is generated. Anywhere between cubes there is a difference greater than 100, you'll see these empty spaces. So the thing we can do is we can fill the world till the negative value, and also you can see is we aren't getting the material on these cubes because we haven't specified the material to be used with instances. So if we go to the material and open the material and go under the usage and tick use with instant static mesh. Now that will just allow this material to be used with instant static mesh, and we'll just give it a different color. We'll go for yellow. One other thing you want, you can give any color, or you can even create your own material, like give your own texture. And if you save this, and it will take some time to compile the material again, and go back and play, you can see you will get the material world. One more thing, you can see these are preview lighting because the world is generated at runtime, so there is no way for the engine to compute static lighting. So the thing we need to do is we will need to specify the directional lighting to be dynamic. So we need to give movable dynamic lighting. Now you may say that dynamic lighting hits the performance a lot, but Minecraft is not that performance intensive on its own, so we can put dynamic lighting. Also, Unreal Engine fully allows many dynamic lights to be in the scene, and it just works fine. If we press play, we get the better lighting and shadows, but we still have these gaps in the world. So next thing we'll do is fill them using Z. Now the method that I am using to fill them is the most stupid method to do it, because I'm just getting the Z value and filling each and every cube from that -1000 to the Z value that I get from here. Now that will work here at this point, and it will be usable if you are creating a really small fixed size terrain, but it isn't game ready or optimized, because the way you should do is that you should only render those faces that are visible, but that is not something you can do in blueprints. You'll need to do that in C++ using procedural meshes. If you want, I can go over a tutorial on that also, but I'll have to research in it a bit. So the thing we need to do is now we need to iterate this Z value from -1000 to the Z value which get from the noise for each and every block. So we'll break this and just move this here. So what we'll do is we'll create a world Z spawn. We'll need two more variables, integers to be exact. So integer this would be the world Z limit, you could say. So this would be the limit, and that would be, suppose -10. This would be multiplied by the cube size, obviously. So we get this limit multiplied with an integer, that would be the cube size. Okay, and we'll need a Z spawn which would be incremented each time we add a cube. So the first time the cube would be added at -1000, then -900, up to the Z value that we get from the noise. So another variable that we'll need is the Z spawn. This would be also an integer. So once we get the noise, we set the Z spawn. So we'll just do this and set the Z spawn equal to the world Z limit. Okay. Next, we get into a while loop. So the while loop will function until the Z spawn is less than or equal to the Z value which we get from this. So we just need to break this. Now we'll do a comparison between these two. So this should be less than equal to this integer, then the while loop will iterate. So in the loop body, what we'll do is increment the Z spawn, because we'll be using Z spawn from here to spawn this. Okay. Now the way these set nodes work is the output of the set node is basically the get of this. So rather than creating this, I can basically use this value from here. So what I need to do is, also I need to increment this. So we'll need to set it again, and this z spawn would be equal to the previous z spawn plus the cube size. So what's the cube size? Again, we'll get the cube size from here, put it in here, the loop body. Then in every loop body we add the instance, and the z coordinate for the instance is taken from the z spawn. If we save this and play, it may take some time to generate the world, because right now it's iterating through 100 into 100 into 20 at max cubes. So as you can see here, we have the z filling, like the world is fully filled to the bottom. So this way you can avoid gaps in terrain. You won't find any gaps in here, but this isn't an optimized way to do this, because right now the world is slow, and even so it is taking about, let's see, 5.5 seconds to generate. So this isn't, because there are many cubes that don't need to be rendered, like cubes in the bottom here don't have any chance to be seen. If we are playing as a first person character, we don't see the cubes below these cubes, so there's no need to render that. So the thing we can do is check around each cube whether the difference between surrounding cube is greater than 100, then only add the cube below the current cube. It's a bit confusing, and I won't be showing you how to do that in this video, maybe in a future video. But this is basically how you can generate a Minecraft-like world. So this is something that I am doing with Simplex Noise and the Unreal Fast Noise plugin and with the blueprints. So if I close this and open another project, like the one which I am doing, in this one, we'll just save all. In this project, I'm using the Perlin noise with C++ from the Fast Noise library, and it's much, you could say in some cases it's faster. Like I've seen differences of 2 seconds in world generation. If I use this is the original blueprint I was working with. If I go to the content browser and delete this and put this, reset it and press play, as you can see, this is faster than that one. Okay, I guess I've not implemented the filling here, but this is easier to implement filling in C++ than that, and this is very much faster than that. So if I go to the C++ class of this and open Visual Studio, I will just show you how it's done. It's not a lengthy code to generate world, because first of all we are using the noise library, so there is nothing much we need to do. Now yeah, so this is basically the code to generate it. Here I initialize the noise function, and these are the 2 for loops inside which there is the while loop. So if I just compile this, I don't know why I wasn't getting the world fill. This a warning and that. Let us play. Okay, right now I'm getting the world fill. I don't know why I wasn't getting it back then. But there are cases like right now my laptop is getting really hot, but I have seen improvements in doing in C++. I'm using Perlin noise. As you can see, this gives a much better output. This is more Minecraft-like than the Perlin noise, than the Simplex noise. We have some plateau formations and all. So I hope you have learned the basics about the terrain generation like Minecraft, and you can play with noise, superimpose two noise functions on each other, a low frequency and high frequency, to get more variation, more special features in the terrain. So just play with it, and this is basically how you can get started with your world generation module. And there are many optimizations that can be done to this implementation, and there are some great videos on YouTube out there, especially Unreal Tuffles. He did a Minecraft challenge in about 24 hours, and he has some great videos, and you can see them and how he has done. And even I will post some videos about generating the world in a better way, but you can get started with this. And if you have a small scale project in which you only need a small size world, then you can readily use this, because it just takes around 4 to 5 seconds to generate small worlds. And I've tried with around 200 by 200, so that's 4 times the size of this, and it takes about 35 seconds to generate that, and that's bearable if you have a good loading screen, that is. So thanks for watching. Please do leave a like and subscribe for more tutorial videos on Unreal Engine. Thank you.